Assalamu alaikum students. In this lecture of redox reaction, we are dealing with the oxidation number, oxidation state calculations. Here we are dealing with the rule number 1, 2, 3 and 4, which tells us about the basic calculations, the basic pattern to calculate the oxidation number from the given elements in the free state or in the compound state. Let's begin the lecture with few examples, and the first example of our lecture is NaCl. Why I'm giving you the very simplest example of NaCl? Because I'm going to tell you a very different method to calculate the oxidation number using a mathematical equation. Like we can convert any sort of charges, like when we are dealing with sodium chloride, the total charges into a mathematical equation just by using the following rules written over there: rule number 1, 2, 3 and 4, and the compound itself. Just look at this example of sodium chloride. If we need to write the oxidation state or calculate the oxidation state of any one of the element, let's say we need to calculate for sodium. We don't know the exact oxidation state of sodium and sodium chloride, so we are going to work out it using the rule number 1. The equation says, the equation that we are going to make says the total charge of all elements combined in a formula must be equal to 0. So we can say that if in case the charge acquired by sodium is taken at as x, right? Since we don't know the charge, we just assume it to be x, plus the next charge of chloride when added gives a total result of 0. That means the next charge of chloride is minus 1. So far what we know. How do we know about the minus 1 charge? Since chloride is basically in group 7 now, so it takes up only one electron to complete the oxidation state, complete its octet, to having 8 electrons. So that means chloride bears a charge of 1 minus. So we have just made equation x plus bracket minus 1 is equals to 0, that shows the oxidation state of sodium when added to the oxidation state of chloride. That gives you a 0. Technically this is your rule number 1, because it also says all compounds are neutral, the total charge must be 0. So just calculate the value of x. Since you have got the equation, the rest is basically the mathematics. So we can say x plus minus minus 1 equals to 0, and x is equals to 1. So there is no charge with 1, so we can say it's 1 plus, otherwise a negative charge is left for the oxidation states which are in negative. Another example is calcium chloride. So since this compound is somewhat different from sodium chloride, how? Because the first compound sodium chloride contains only 1 Cl, the second compound calcium chloride contains just 2 Cl atoms with it. So applying the rule number 1, making an equation that if we were to calculate oxidation state of calcium, let's take it x, since we don't know the oxidation state of calcium, adding the second one. But keep in mind that since we are dealing with the two chloride ions, the charge of one chloride is 1 minus, right? So for 2 chloride it must be 2 multiplied by minus 1. We can conveniently say that if one chloride bears a minus 1 charge, what is the charge of 2 chloride? So this is a simplest way to calculate it. So the total charge must be 0. The first element is calcium, that is x. The second element is chloride, that is minus 1 multiplied by 2, just because of the quantities of chloride, and that is equals to 0 according to rule number 1. Just look at this solution. X plus minus minus 2 multiplied by 1 is 2, that is equals to 0. And if x to be calculated, it becomes x is equals to 2. And if there is no charge, definitely the charges and positive. And you can also verify that x is 2 plus, the calcium charge is 2 plus, since the rule number 3 says the metal acquires a positive charge on the basis of its position in the periodic table. So this is, we can say, oxidation state calculation on a very normal scale. Let's begin with some different and difficult examples. For example, a compound that is KMNO4. This compound is called potassium magnate. I should write the name so you guys can actually memorize. This is going to be again and again the part of the lectures. So this is called potassium magnate 7, or it is also called potassium permanganate, right? So in either way, well, in the convenient form is the potassium magnate 7 that actually gives you the oxidation state of the compound. This is the oxidation state. If you have taken the lectures from the periodic table, in which the transition metals were actually held with some compounds, so those compounds of the transition metals actually having a Roman written oxidation state with them. For example, iron sulfate is not appropriately written, it is iron 2 or iron 3 sulfate. So the 2, 3, 4, 5, 6, 7, whatever the number we express in the Roman is basically the oxidation state. So this is also the oxidation state of an element which is called manganese in this compound. We are going to just find it out. Let's take the query as calculate the oxidation state of this manganese, right? So apart from this manganese, the other elements oxidation state or their charges should be known. So far what we know about potassium, it's the value for potassium is taken as plus 1. Why it's plus 1 or minus 1 or whatever the value, it is dependent upon the position in the periodic table. So potassium appears in periodic table group number 1, so it loses one of the electron, making it plus 1. Sorry. Second is the manganese. Since we don't know the charge, so we just take it x plus 4 times oxygen. One oxygen bears a charge of minus 2, right? So one oxygen bears a charge of minus 2 means this is minus 2 and the total charge is 0 according to the rule number 1. Just I am explaining it again, this line plus 1 is for potassium, x is for manganese, and 4 times minus 2 is for oxygen. Since one oxygen acquires a charge of minus 2, the 4 times multiply that must be something. So the total charge must be equal to 0 according to the rule number 1. So we have already applied it. Now you need to calculate the value of x in it. That is basically the oxidation state of manganese Mn in the given example. Let's work it out. 1 plus x, this plus and minus gives the total result of minus 4 multiplied by 2. 4 times 2 is 8 equals to 0. Right now on the left side we have 1 plus and minus 8. This gives us the result of minus 7. On the right side is equals to 0. When x is calculated, x becomes 7, and if there is no charge with the 7, that is considered to be positive. So we can say that in compounds where there are multiple elements are combined, so in order to calculate the oxidation state of any one of the element, the rest of the elements oxidation state should be known or should be given. So in this case of KMnO4, the oxidation state of manganese Mn is 7 plus. So this is what I just gave you as an example, that plus 7 is basically the oxidation state. So this is how we write in the Roman 5, 6 and 7. Hopefully you all have understood the example of KMnO4. Let's switch to another different and difficult example of another compound, which is called K2 Cr2O7. This is uh, completely different from the others, since it needs one more arithmetic operation to solve the equation, which we are going to take. Well, this compound is called potassium chromate 5, 6, right? So this is called potassium chromate, or alternatively we can call it potassium dichromate. So if you are not willing to show the valency or the oxidation state, you can say potassium dichromate, or otherwise the O levels convenient method is potassium chromate 6. Well, when it comes to K2Cr2O7, we need to calculate the oxidation state of chromium, that is Cr. But keep in mind that we are dealing with the two chromium atoms, so the equation is going to be different from the previous equations. Let's talk out the equation first. On the first of the elements are potassium. Since we are dealing with two potassium, so 2 must be written. The charge of one potassium is plus 1, right? So this is just for potassium. Plus the next element is chromium, Cr, and the total quantity given is 2. 2 times the charge of chromium. Since we don't know the charge, we take it x. At the same time, 7 times oxygen, and oxygen means minus 2, gives a total value of 0. This is basically the equation that we have created, and now we have to solve it for x. 2 1 plus 1, that when it is multiplied it gives a result of 2, plus the 2x already given, uh, plus minus is minus, 7 times 2 is 14 is equals to 0. 2 plus and minus 14, that gives a total result of minus 12 on the left side, that is equals to 0. And now 2x is equals to 12, and x is equals to 12 divided by 2, that gives us the total result of 6. And as I've told you, if there is no charge given with the number, the charge considered is positive. So we can say the metal is positive. The chromium has a charge of 6 plus, the oxidation is 6 plus in K2Cr2O7, and you can also identify it using this area in the name, which is also 6. So this 6 in the potassium chromate actually represents the oxidation state of chromium in the compound. So these are some basic examples and basic calculations that you need to adopt to calculate any kind of oxidation state of any element in the compound if the other elements oxidation states are given. Let's do some maths for H2O. Since H2O is a molecular compound, but still it is ionizable, and it ionizes to give H positive and OH negative, so we just consider that to be an ionic compound for this instance, so we can calculate its oxidation state. Now we have an example of, where should I write it? Okay, I'm just writing it here, H2O. Just consider that 2 times hydrogen and 1 oxygen combines to give H2O. We need to calculate the oxidation state of hydrogen in this compound. So we can say that 2 times the oxidation state of hydrogen, that is, since not known, so it is x, plus the oxidation state of oxygen, that is, so far we know, is minus 2. Based on the group number, the total charge must be 0. So we can say that 2x plus minus minus 2 is equals to 0, and the calculation suggests x is equals to 2 divided by 2 gives a total value of 1 plus. So we can say that hydrogen in the oxidation state of 1 plus in this example. So we can say hydrogen is 1 plus. At the same time, we say the total charge of hydrogen is 2 plus. How is it possible? Because the compound contains 2 hydrogen atoms, and if one hydrogen has a total charge of 1 plus, the 2 hydrogen atom must be having the total charge of 2 positive. And in order to nullify the 2 positive, the oxygen acquires a charge of 2 negative, that gives a total value of 0. Hopefully I have written the 2 negative and you have got got it. Okay students, this is done with the redox reaction oxidation state calculations, and hopefully what I'm going to give you as an example, you guys are actually able to solve it. Since this lecture is about the oxidation state, so we are not dealing with any kind of reaction. In the next video lecture we will discuss the oxidation state its value, and how can we identify whether oxidation and reduction is taking place on the basis of oxidation number. So till then, practice for this kind of concepts. Allah Hafiz.